Um, Welcome everyone, I'm Jimi, this is Evan. This talk is Consumer Routers Still Suck. Covers a bunch of research we've done into consumer routers and networking devices over the past 2 or 3 years. Gonna start by going through a bunch of rapid fire vulnerabilities for kind of the stuff everyone's familiar with, the Netgear devices, your TP-Link stuff that you've got on the shelf at home. We'll talk about going over a bunch of ISP provided devices, things like Eris modems or Buffalo or Arcadian. Then we'll kind of talk about how new things are going. So like your Eros or your Griffins, things that are doing more app-based management instead of the traditional web GUI things. We'll kind of talk about why all of them still suck. So all of the stuff you have from the mid 2000s up till literally yesterday, and all of them we still keep finding the same vulnerabilities over and over. And we'll wrap up kind of by saying why that's the case and why it matters. So about us, we're both security researchers at Tenable. This is by no means a sponsored talk. We're giving them a shout out because they give us the time, money, and resources to actually do this thing, and that's really all you need to know. Get right into it. I'm going to make a bunch of generalizations for the sake of brevity here. So if there's any sort of technical mistake, I apologize for that. RVAsec is kind enough to post all the slides, and we've got a giant list of resources and write-ups for exact specifics if any of you want to go through the code or work through any of this yourselves. That'll be made available at the end of the presentation. I'm going to start out by going through 3 Netgear devices. All of them say Nighthawk. None of these are the same device. Some of them will share front ends but have totally different back ends. Some of them will have the exact same back end, totally different front ends, and it's very confusing and there's no rhyme or reason as to why. So we'll start out, I'm mentioning this just so I can mention it again later. This was a pwn2own target for 2022. General framework for kind of going through how we look at these devices and approach them as research targets. This is covered by other researchers ad nauseum elsewhere, but just a quick little overview. Figure out how it works, figure out what it's supposed to do, get root on it, get the firmware, start taking it apart, and then start searching for vulnerabilities. That's most of the way to it. A lot of times, as in this one, the vendor is kind enough to include pins for you to connect to yourself. So look for UART headers, JTAG headers, whatever. Luckily, this one, as soon as you connect to it, drops you into a shell. Fairly simple. This one was a restricted shell with only a subset of commands enabled. So we'll talk about how we got around that later on. But it also had scripts to enable a telnet backdoor, which is available on most Netgear devices. This one didn't have it enabled by default because it was slightly different. A couple modifications, still works just like all the other Netgears. All that code's available online. Additionally, I have a very tiny home office, so I can't have cables for serial UART. I like to make shells that are repeatable, so when I reset the device, I don't have to dig everything out and hook it all back up. Luckily, Netgear is kind enough that all of the file sharing utilities on these, if you plug a USB in, it's available on LAN by default. If you just make a symlink to the root directory, you now have root access to the device. Put it all together, it also interprets PHP, so put a PHP web shell on your USB drive. No matter what, when you reset the device, you still have a root shell on the device. Once we can get into it, we can look at what services are available. As I said, the ReadyShare service, we've already proven that's vulnerable, and we can use that just to get a repeatable research environment. There's the main web server and administrator UI. There's a SOAP server running on port 5000 for mobile apps, or there's a desktop app to also manage these. And then Telnet was enabled. IPv4 rules were same. We'll talk a little bit about one of the rules that wasn't here in just a second. But as you'll see, nobody remembers IPv6 exists. All of these services on the device listen on IPv6 on all interfaces, including WAN. So all of this was vulnerable from the internet. So since Telnet was enabled and listening on WAN, there's a hard-coded support account, support. It's an administrator account. You can access that from the internet on all of these routers. Unfortunately, it still drops you in that restricted shell, but it pipes everything to a system call. So the world's easiest command injections will get through it. Any request also, that IPv4 rule, there was an application called PU HTTP sniff. For whatever reason, it piped the user agent to a system call. So you have command injection. Unfortunately, literally 3 days before Pwn to Own, everyone else found this, but Netgear also found it and patched it. So like I said, I mentioned it to mention it later. Didn't really matter because all the vulns from the 90s and 2000s, format string, buffer overflows, no protections, all still work. The year was 2022, and this slide doesn't show it very well, but literally a string cat to an SN printf gave you a format string. You overflow it, you insert a command into it, and there's format string attack in 2022. Consumer routers still suck. All of the traffic management and CGIs, literally just put a bunch of A's in, and you have a memory disclosure. Unfortunately, this doesn't have remote code execution, but other teams did prove it during the event that it was. We just didn't have time to find it. Some weird stuff. All of these also, for whatever reason, one of the content type headers, if you gave it content, it just wrote it to a file on the device. We don't know what it was used for. We don't know why it did it, but if you filled it up, you filled the disk and bricked the device. This is the least sexy part. Most people don't really consider this vulnerabilities. We do, just because vendors don't intend you to be able to modify firmware. They all use hard-coded encryption values for their firmware signatures. Just copy those signatures. They don't let you update the device yourself unless you use a hidden force firmware update flag. So you upload custom firmware, you sign it yourself, and can't really see it on this slide, but it shows firmware being applied successfully. Moving on to a different device. Recon is the same for all of them, same UART headers, similar to the config values. All of these are configuration values piped directly to a system call. Configuration values piped directly to a system call. Configuration values piped directly to a system call. Not to mention, every service on this device has old, known vulnerable, known public proof of concepts available, just same stuff. Next Netgear, another, vulns from the early 2000s, buffer overflow, sets an unused variable, hits an API endpoint that supposedly requires authentication, but contains a command injection vulnerability. Another one, command injection, just feeds all of these directly to system. This is another Pwn to Own target, and a lot of teams also found this. The reason I'm mentioning that is because we didn't figure out that it was available on WAN, but these were vulnerable on the open internet, and then within days of the event, all of these vulnerabilities appeared in Mirai botnets. TrendNet. Most people aren't familiar with this, but it is one of the top sellers on Amazon, at least at the time we had this. It's something that I had seen in a bunch of Airbnbs and coffee shops. So we bought one just to see why it was popular. Turns out, because it's cheap and it sucks. Information disclosure. So all those like setup wizards, when you first set up the device and provision them, you couldn't re-provision the device, but all the pages were still open. It redirected you to anything behind authentication if you click the cancel button. So you just change the redirect and you get all of the config values, such as the admin password or SMB password. CSRF, I don't know if they know how it works, but apparently if you just provide any value, that counts. There's no actual CSRF token. There's no validation. You just give it a random number and it works. Admin password, it's just an API endpoint. You change it completely unauthenticated, including with CSRF. Other issues, IP-based session handling. If someone has a session to, say, the BitTorrent client or the file shares or anything else, spoof their IP address, you now have their session. More hard-coded config values, more hard-coded encryption. Every single config value on this thing was fed directly to a system call. Oh, and there were no IPv6, so all of this could be done on the open internet. So say you have like an ARIS modem that enables IPv6 or IP pass-through, and it's like exposing your network to the world, as almost every AT&T customer has. Don't do that. More trends. Like, as we've kind of touched on, nobody knows IPv6 is there. None of these vendors account for it until they're told, and even then, they don't patch other devices. Everyone tries to obfuscate their images, but they're still using stuff from the early 90s. Command injections, buffer overflows, stuff that shouldn't exist in 2024, still finding it. Modern web functionality, CSRF, all of them vulnerable. Brings us to something, raise the barrier to entry a little bit. So these are things that your ISP tends to force upon you. You can't configure them, you can't update them yourselves. If you're provided one modem, it might be different if you go to Spectrum. It might be different if you go to AT&T or Verizon or whoever, because they all maintain their own versions of these firmwares. But if you happen to get lucky enough to get an unprovisioned one, you can take it apart and see what's in it. There weren't any test points on the board, so we had to get a little creative. All we cared about was getting the firmware, since none of the vendors allow you to download it from their websites yourself. So we took the chips off, put them in some sketchy adapters we bought off Alibaba, dumped it, and now we can investigate. Turns out there's an API endpoint, change the admin password. There's no CSRF protection, so any watering hole attack. I know those aren't necessarily the sexiest thing in the world, but as you'll see in a little bit, hundreds of thousands of routers have been compromised by that over the years. But again, with Eris in particular, they are owned by CommScope, who sells to all of these major internet service providers, who then sell to even more smaller internet service providers. They all maintain their own patches. Customers aren't allowed to touch them. Some of them may not update ever. So things get very, very tricky very, very quickly, as we'll kind of see. I know I rushed through that, but there's a reason. We'll jump over to Evan.
Yeah, so back in 2021, I was looking for like the most popular routers on Amazon Japan, as you do, right? And very popular set of routers at the time I hadn't really heard of were from Buffalo Technologies, and I'd heard of Buffalo before. They produce NAS devices for the Americas, but they don't sell these routers in the Americas. This screenshot is actually from last week. Still Amazon's choice in amazon.co.jp is a Buffalo router. So found a bug which was a path traversal, pre-auth path traversal. So basically what it was doing is before you had authentication, still needs to load up the login page, which it needed a couple of images, needed a couple of JS files, what have you. It would check whether or not the URL it was reaching out for was in one of those folders, but it was basing the length off of the list it was checking, which is just to say that if you gave it this URL up top there, it would only check that you actually put in /images at the start. Anything after that, it wouldn't check at all, and so you could do the easiest path traversal in the world, and you have, path traversal, so you have an auth bypass. Mix that with some post-auth config file injections, and you have full RCE as root, which, given this was like a consumer device, pretty cheap, not too bad. There weren't a ton of them on the internet. A lot, but not a crazy amount. But we really ran into issues when we started looking. So something we do when we do these disclosures is we'll take a look on things like Shodan and Census and Binary Edge, just to see what is out there in terms of vulnerable devices. And when we started looking, we noticed, okay, yeah, a lot in Japan, but what were these devices in Germany, in Spain, in Argentina, and Singapore? And so you click in on one of those ones from Germany, and it says it's an O2 box. O2 Telecommunications is an ISP in Germany, really big one. Turns out that what we were looking at was not just a vulnerability in the Buffalo routers, but a vulnerability in the underlying Arcadian firmware. Arcadian is a Taiwanese company, and they manufacture a number of devices for all sorts of vendors, whether that's like commercial off the shelf or for ISPs. It also turns out that this code that was affecting all of these different vendors and all these different ISPs and led to this path traversal went back to at least 2008, probably around 2006, and is in a large number of more devices than we really knew how to handle. We'll talk about that a little bit more later, but suffice to say, it really caused a lot of issues with disclosure, because how do you reach out to dozens of ISPs across a bunch of different countries to fix a single vulnerability that is spanned across like decades? And then some new kids on the block.
Yeah, more or less this slide is just to kind of talk about new entries into the game. So your Eros, your Griffins, things that don't have the traditional web interfaces, things that don't have like, direct access to the device. These are marketed more to be user-friendly, kind of plug and play. You set it up with your app like on your phone for anyone to do, and then move on. We were curious to see, are these vulnerable to the same things we've been talking about or finding for the last 2 or 3 decades? Turns out, yes.
Yeah, so this was a router, again, just looking around on Amazon. It's fun to just go on Amazon and see what like comes up when you put in the word router. One of the ones was Griffin. We looked into it. It was a startup producing new fancy router that, yeah, it was advertised as more safe because it doesn't have a standard web interface, which is how a lot of those bugs that we've been talking about, like that's where they occur. Regardless, it had at least 7 unauth command injections when we took a look at it. And it also had a very super cool new feature, VPN feature that lets you connect to your home internet when you're out and about. So you would install this app on your phone, and then when you're out in the world, you could connect back to your home router through a VPN and access the internet that way, because Griffin would be securing your home internet, so it's safer, ostensibly. But yeah, so they say even in their advertising that web interfaces can open the device to significant security risks, and because of that, they don't have one. So what they do have is a phone app. So we went and grabbed the Android APK and pretty quickly realized that what it was doing was just, again, communicating over HTTP, but just from this phone app, and you can't see that link yourself when you're looking at the web interface, but the phone's still doing it. And so we got access to the underlying device. Griffin was nice enough to provide UART headers, like Jimmy mentioned before, and so you could get a root shell on the device and take a look around. It was running Lucy, and I'm not sure if any of you have been looking at this while I've been talking, but yeah, it's not quite system, but the Lucy equivalent of that is running os.execute on a command of unsanitized parameters. So sending a post parameter and injecting any one of those SSID, hidden key SSID file, any of those, and you've got a command injection that's running as root on the machine. Yeah, a little example here. Everybody loves a GIF. Yeah, all right. So, I mentioned before the Griffin homebound system. So, you connect with your mobile app, and when you're out and about, that means you're going back through your home internet and then out to the internet. So the way that it does this is when you sign up for the homebound system, it downloads an open VPN profile to the device. Well, it turns out, again, we had root access to the device already. You can just take that open VPN profile and use it as you will from your own machine. And when we did that, we noticed that not only was our device attached to that VPN, but so was everybody else that had signed up for the homebound system. So, and it was also exposing the LAN interface. So all those command injections we just found are also showing on every other router that had signed up for this device. It's isolated now, they fixed it, and they were really, they were good to talk to for that, so that's nice, but like, yeah, imagine our surprise when we signed up for it, and all of a sudden we're seeing other people's LAN interfaces connected to ours. It's not good. And then, so that was like a new fancy feature, VPN feature. Phone apps are more common, like they're popping up, like TP-Link has them, Netgear has them, everything else. Another thing that a lot of those vendors are doing is creating these cloud management systems so that you can manage it from anywhere in the world. You can manage your home router, which is great. That's cool. An instance of this in 2020, Grandstream has their GWN cloud. A researcher named Vangelis Stikes for Pen Test Partners at the time discovered that when he was editing his user in that cloud system, if you see there the highlighted, the network IDs, it was adding and registering a user to this network ID. Well, it turns out you can see it's an array there. If you just add other numbers, like it's 16,089 there, add 16,090, then you have control of the network 16,090 and their device, which means you can control somebody else's router if they've signed up for this service. And based on that number, Evangelist was saying, well, it's probably at least 16,000 customers that you could do it to, right? 16,000 devices, so who knows. Grandstream fixed this, which is great. However, when the researcher was revisiting this in 2023, he said he was playing with his son and teaching his son about IDOR, insecure direct object reference vulnerabilities, and he went and tried this again. For whatever reason, it worked. So at some point after fixing it, Grandstream had reintroduced the bug, and so he reported it again, and they fixed it again. So some homework if you're interested. We haven't looked, but maybe go check it again in a year or so, and who knows, right?
So as we kind of alluded to at this point, things are all the same across the board. It doesn't matter if you're a new vendor, it doesn't matter if you're an old vendor. But what if you're a vendor that doesn't exist? What if you buy stuff from Eris and then are no longer an Eris customer but still need updates? What if you acquire an old Eris subsidiary? What if Arcadian was part of Acton and then split and then reacquired and then sold to yourself? And it gets kind of crazy pretty quickly. We'll come up with an instance here in a little bit where sometimes you might end up with a device that's labeled one thing. The PCB is stamped with the logo of the thing you bought, but you boot it up and the firmware is not that device. The whole supply chain is really, really, really weird, and it makes disclosure really hard, and it makes it really hard to kind of pin down who you're even supposed to talk to about it.
Yeah, so like as I mentioned with Buffalo, it was a Japanese company, at least for the router portion. And on the Japanese site, they have a form where we could disclose the vulnerability, and so we did. We didn't get a response. We tried, I think, twice and didn't get a response. So we reached out to Buffalo International, Buffalo Technologies International. They had privacy Buffalo at buffalotechnologies.com to report vulnerabilities. They didn't respond. And so we finally reached out to Buffalo Americas, and they actually responded, which is great. And they got us in touch with the Japanese portion of their company, and we were able to disclose to them. But then we found out that it wasn't just Buffalo, it was Arcadian, and so it was a bunch of other vendors, which complicates things, right? So this one CVE affected, at least 13 ISPs across 11 different countries, and that's before counting non-ISP devices. So all the other ones like Buffalo themselves, they're not an ISP, they just provide devices. And so we don't really have the resources to disclose that. Like, I'm not sure if anybody in the crowd has done disclosures before, but it can be a tough process just because there might not be, even with Buffalo, it was hard to reach out to them. They might not respond. And managing that with a single company is already difficult. Managing it across 13 in different countries, very difficult. So we reached out to the CERT Coordination Center at Carnegie Mellon. They're very used to doing this kind of thing. And they have connections with other CERTs across the country and across the world. So they're better at doing this, and it kind of raises the profile a little bit so that vendors, even if they're not informed, can see and maybe figure it out that they are affected. Which is something that happens because even just looking into this, there's a site that we often use called fccid.io. It's for devices that are registered through the FCC. If like you're a Wi-Fi device, you have to. And so you can go look at like Arcadian and see all the devices that they've registered and are registered as the manufacturer. But Arcadian themselves they were created in 2003 and then sold off in 2006. But the company that sold them off still created other devices that seemed to use the Arcadian code. And so like, who do you get in touch with at that point? Is it with the old company for like 12-year-old routers, or Arcadian themselves because it's their code, or the original parent company? It's confusing. And so like a lot of the time, if it's that big, you have to go through somebody like a CERT Coordination Center just because they're used to dealing with that kind of thing. One more example, since I think we're doing okay on time, yeah. Last year, we decided to take another look at some of the devices. When this first happened, I tried to purchase a bunch of devices from across the world just to see and test so that we can make sure we are correct about our assumptions. Like, we would see them online, but like, I'm not gonna go exploit somebody else's router. So you buy some stuff on eBay from ISPs, and I bought one from Australia. It was a company called Telstra. They're a big ISP in Australia. Ended up finding more command injections, post-auth and pre-auth for their devices. When we reached out to them, it turns out that they no longer have a contract or like worked closely with Arcadian. They'd moved on. They have a new model, right? But they still had Arcadian devices out there on the internet. Like, customers still have them. And Telstra was really good about this. They said, we're going to reach out to Arcadian. Arcadian will provide a patch, hopefully, and then come back to us with that patch, and then we'll have to push that patch across a bunch of different networks across the country. And it's just a long, arduous process, especially in cases like these where like they weren't working with Arcadian anymore. And so it's again, it's hard to know who to report to and how that works from a disclosure process. We're going to go through some other examples here. This was work done by a colleague of ours, Olivia Luca-Fraser. We mentioned her talk at Recon here, but she also did this talk at Atlantic Security Conference in Halifax, Nova Scotia, which is where I'm from. Daryl McLeod is a member of the board for that conference, and he's here. He has a talk tomorrow. Go watch it. But yeah, she did some amazing research, and you can check out her blog for it too, because it's a very lengthy blog, very interesting, and crazy great work by her. But basically, yeah, we'll go through here. Like we were doing, ordering cheap routers from Amazon. This one was like a $35 router called a WavLink device. But when Luca got the router and booted it up and went to log in, it was a FICOM device. And we hadn't heard of FICOM before, and we don't know what it was, and so she started digging. During that digging, she designed an amazing tool that lets you make use of a backdoor in the FICOM firmware, but get complete root access unauthenticated to every FICOM router that exists. So that's really cool, and she's amazing, and you should definitely check out the work because, yeah, she's great. But one of the most interesting parts is, why did this happen? Why did she have a WavLink device that she bought on Amazon that had FICOM firmware on it? Well, it turns out that FICOM was a really big company in China. They were mentioned in the same vein as Huawei at the time, but the CEO and founder at some point entered a business deal with a peer-to-peer lending group called Lianbi. It turns out he also started Lianbi, the peer-to-peer lending group. In 2018, the Chinese government was doing a crackdown on shady peer-to-peer lending companies, and they shut down Lianbi. And at the same time, that kind of crashed FICOM, and so they sold off all of their router stock. Later in 2021, the CEO was given life in prison for fraud, and all of his property was taken and everything else. So yeah, that's him at the trial and other people from FICOM. But yeah, so what happened was they sold off all their router stock as they were shutting down, and they sold off to a company called WavStars. And WavStars has a subsidiary named WavLink, or WavLink, or yeah, WinStars, sorry, and WavLink is their subsidiary. And WavLink apparently was selling routers that they had their own WavLink devices and did have WavLink firmware, but then sometimes, I guess, you get lucky, luck of the draw, and get a FICOM one. WavLink did respond to Luca and said that they had patched this issue in their own devices, but anybody that still had FICOM firmware, you're out of luck, and like they're just going to be vulnerable forever. And there's still a lot of them out there. Now, it doesn't just stop at like the manufacturer at like the Arcadian level. A really common manufacturer of systems on a chip, Realtek, provides chipsets to router manufacturers like Arcadian and others, and Eris. And sometimes the bugs will be in the tools that are shipped with those chipsets. So you are building a router and you want a chip to run it. You get a Realtek chip. It comes with some binaries and standard tools that let you run things. OneKey did some amazing research where they found some critical vulnerabilities. And because it was in these Realtek tools that get given out to a ton of different manufacturers. It affected 65 vendors, tens of thousands of devices online. Faraday Security, same thing. A few years later, they did an amazing talk at DEF CON on this. They found a vulnerability in Realtek ECOS, a real-time operating system. They bought this Next device not knowing what they would find, but they went and found this vulnerability. And then, much like these previous cases, turns out it was in the Realtek AP Router SDK, which is part of those chipsets. Those chipsets are then installed on dozens of different routers from dozens of different vendors, ends up affecting thousands of devices. Yeah, so Next, D-Link, Tenda, and there were a ton more. Again, highly recommend going and checking out that research. It's a great talk.
Yeah. So we've blazed through a lot of this, but the whole point of this was to more or less demonstrate that these vulnerabilities are everywhere. The whole supply chain doesn't really make much sense, or it does, but I think we've made the point that it's very, very complicated. But does anyone care? These are like home routers. What value is there in that? And turns out a lot of threat actors care.
Yeah, so even just anecdotally, like I'm not going to go through all this, but there's work from home research done by like Stanford and some other real universities and super smart people that do stats stuff. But even anecdotally, pre-pandemic, there weren't like working remotely happened, but it wasn't as common. During the pandemic, huge, crazy, right? Everybody's working from home. And even now, we're still way, way ahead of where we were pre-pandemic in terms of work from home. Enough that like 28% of paid days in March 2024 were work from home days. So even if you're not working from home all the time, you might work from home 1 to 2 to 3 days a week. Like, and in fact, like hands, who works from home at least 1 day a week here? Yeah, that's a lot of the room. Yeah. While it's not necessarily an issue, and there aren't examples that we have off the top of our heads of people being attacked directly at home for the reason that they're an extension now of their corporate network infrastructure, right? You're working from home. If your security hygiene at home isn't amazing, then you might be a target, which, I mean, zero trust architecture is great and everybody's going towards that, so that's awesome. But again, this still is not amazing. And makes it a juicier target. But even without that, even if you're not trying to attack people in the network themselves, you can still use these devices as cheap computation. So Volt Typhoon, they're a threat actor that has been attacking critical infrastructure in all sorts of industries, but like very serious critical infrastructure. And the way that they use this is they infect all of these old, bad, end-of-life, or very vulnerable commercial off-the-shelf devices, and they use them as proxies, basically. They use them to anonymize their traffic and use them for their command and control to then attack critical infrastructure. So instead of like attacking from where they are, they're attacking from some guy in like rural Canada's router is now attacking critical infrastructure, not the threat actor. Another group called The Moon does this as well. They also target these devices. Like it says there, this research was done by Black Lotus Labs of Lumen Security. Again, highly encourage you to go read that because it's really great work. But what they discovered there was that The Moon wasn't just doing this. They weren't just infecting these devices and using them themselves. They were then providing that access to a cybercrime group named Faceless. What Faceless does is sells these anonymous access or these proxies as a service, basically. So if you want to go do some cybercrime, you get in touch with Faceless. They give you access to one of these devices, and then you're anonymized. You're going through these proxies that are other people's routers. And the Mirai botnet. That's a classic one. They've been around for a long time now. They're mainly used for like denial of service attacks, DDoS. It's very fun that they started as a Minecraft thing. I'm not sure how many of you are aware of that, but basically a guy who sold services to stop DDoS attacks against Minecraft servers wanted to attack his competitors, and so he made the Mirai botnet. But yeah, now there are like 13 variants of Mirai, and it's huge. And in some really big attacks, back in 2016, they took down 900,000 routers from Deutsche Telekom because of like an erroneous attack that they did. And that can be really bad. Like even if that's not the attack itself, even if it's just a mistake, taking down 900,000 routers, I mean, that's going to interrupt a lot of people's work. If you're working from home, it's going to interrupt a lot of people's lives, right? And how many of those are small businesses? How many of those are medium businesses? Like was talked about in the keynote this morning, right? These devices you don't control. You don't necessarily get to pick. Your ISP gives them to you, and then they get owned like this, and you're out of luck. Yeah, and then we were happy that this, well, not happy that it happened, but it was it was timely that this happened last week. More research by Black Lotus Labs out of Lumen. But just last Friday, this was reported, mystery malware destroys 600,000 routers from a single ISP in a 72-hour span. That was here in the States. So 600,000 small home office routers, devices, yeah, attacked. We don't know why yet. Like, they were infected, but they basically just bricked the devices. So not sure what the intent is there, but it's still not good. It really, I mean, if you were working from home and you live in a rural area and your router is just suddenly bricked, not great, right? Like, it's not, that's tough. And even before we get to this, I'm just going to mention another one that popped up yesterday because, yeah, it just keeps happening. And this is a little bit different, but there's some excellent research from Sam Curry that came out yesterday. And it was that Cox, the telecom company here in the States, they had allowed unauthenticated access to their management services that allow them to manage these devices across their entire network. And it was something like millions of devices were able to be controlled through these APIs that Sam Curry was able to access unauthenticated. And this wasn't just individuals, this was businesses. One of the notable examples that he cited was FBI field offices. So not great, right?
Skip this.
Yeah? Okay, yeah. So yeah, we put together these quotes here. You can read them, they're cool. But basically, Jimmy and I are offensive guys. We mostly work on the offensive side. There are blue team recommendations for how do we get around this. Some of them were mentioned this morning during the keynote. But it's mostly regulations, right? This won't change without a push from the regulatory side. There are other ways, just practices like secure development life cycles, software bill of materials. How helpful would it be if we just had searchable, repeatable software bill of materials, which is just a list of all of the libraries and software and hardware that are associated with a device. So if you're given a home router, you know who that was manufactured by, what open source software is on there, what proprietary software is on there, who makes it, who, like, if you know that chain, it's going to be a lot easier to figure out who you have to get in touch with. So that's a recommendation. The White House has put out statements on this. The National Telecommunications and Information Administration, they have a site where they've got, and these links are in our references, but they've got recommendations on how to start doing this at your own company. And yeah, but really a big recommendation from us, because again, we're more on the offensive side. We don't know too much about the blue side. Hack the planet, basically. Like something I've said before about these devices is that like they are from ISPs that are effectively region locked. Like we were able to get a couple from Australia and other places, but that's only because we found them on eBay because somebody's selling them when they definitely shouldn't be, right? Like, I don't know, you're probably not supposed to sell your ISP's device, but a couple bucks. But yeah, these devices, you can get them from your ISP and start taking a look at them, or maybe like the ISP a city over or something, who knows. But like, it's a very fun activity, and it's a great thing to do if you want to kind of dip your toes into this kind of offensive security, because like Jimmy has stated, with all the vulnerabilities he covered, and like we went through, it's like hacking like it's in the 90s. These are like stack buffer overflows that have no mitigations. It's web vulnerabilities like path traversals, where you just throw in a single like ... / and you're like, oh, sweet, auth bypass. Which incidentally is also not fully like it's the 90s. I don't know who's been paying attention to all of the SSL VPN and enterprise firewall vulnerabilities lately, but it turns out even the very expensive devices are also still affected by these kinds of bugs, path traversals, very easy command injections. But yeah, like I was saying, these routers are really fun. They can be like 35 bucks, but then you can get your hands on some hardware hacking. You can do some binary reverse engineering with Ghidra. It's free now. You can then go do some web hacking with Burp Suite. Now that they're doing all these cool, fun new features, you can start dipping your toes into mobile app reversing. Start with Android. You can literally just unzip Android apps. It's great. And then now, I mean, they're starting to do cloud. So, well, that one maybe don't start poking around just yet. But like, yeah. But yeah, we encourage you to go hack them.
Yeah. And I think we hid enough slides. There are like 120 in this deck, and kind of rushed through enough that we're actually going to come up with plenty of time to spare. Just quick shout outs to these guys. NCC Group and Synactive, we use their blogs for years as like inspiration or even tutorials on how to do a lot of stuff. The consumer router industry would not get near the attention it does today without ZDI for sponsoring giant, huge prize pools for literally taking apart $30 devices. And then, like we mentioned, the Faraday talk earlier, that was from 2 years ago, and it's basically this exact same talk. They found a couple of vulns that affected hundreds of thousands of devices across the world for like dozens of different vendors. So I would definitely check out their talk as well. Other than that, all the slides, including hidden ones and all of our references, follow this link and you'll have it. It includes a bunch of write-ups, a bunch of like actual technical things if you care about the details. And yeah, thanks for coming. Good enough. Sorry, hold on to this one. Oh, you're good.
Oh yeah, we got time for questions. So
yeah.
So do you see this getting better or worse as more companies switch over to things like fiber internet, and we sort of kind of lose the classic cable modem combo?
So I can actually talk about that as of like 2 days ago. No, it's going to stay exactly the same. So most fiber companies will use a standard cable modem and then use an ONT adapter. So it'll still be like coax cable on your end and then fiber into an ONT box to you. Some of them will go directly into the modem, but it's still the same underlying infrastructure.
So they all suck. Which one sucks the least? We need these in our house regardless, right? So which
Yeah.
one do you guys have in your own house? I'm still going to protect it. Or, what do you recommend?
Do you have an answer?
I don't really have a great recommendation. I've got like 16 layers of firewall. No, but like my own security hygiene, I'm like, yeah, no, I've got something there that is okay, but like nothing special, and I think it's just provided by my ISP actually. But like a fun thing to watch, I'll say this. Go through the pwn-to-own results from the times that they're doing the routers, and just watch to see if one of those routers doesn't get popped, and then maybe you just buy that one. Because if the guys at pwn-to-own aren't popping it for money, then I don't know, it's probably a little bit better than the rest. Sure.
Have you guys done any research on small business or mid-sized business gateways from like Ubiquiti, Netgate, or any of the other companies like that? Because a lot of them are just badged, rebadged versions that run the underlying same chipset or same firmware. So curious if there's any
So the rebadge stuff for small business is usually like the bottom of the barrel stuff provided by either Cisco or Juniper or whatever, and then a Spectrum logo slapped on top of it. Barrier to entry for those tends to be pretty high, so we don't have a ton of experience or resources there because they're just hard to get a hold of. Ubiquity is a special case. We do have some stuff published on Ubiquity, but not a ton of research there. Our experience with them, though, has been not great, just because if you disclose, they don't like it. So nobody hates Ubiquity more than the people that love Ubiquity, is what I'll say there.
Would MikroTik fit there?
They're an ISP.
Oh, okay.
Any other questions? Either. Fight each other.
Curious, have you done any research on DWRT or OpenWRT?
I don't think either of us have, but a lot of what we kind of include here is like the firmware, like signature bypass and stuff. That sort of thing is what's most useful to those communities and why we kind of still think that's important to touch on. I don't know if that really answers your question, but. We have a few disassembled ones, but nothing ready to publish yet. So, go ahead. Yeah. Yes and no. So the software that they're producing is great because it's vetted, but a lot of times they'll contract out to these other vendors who have been doing it for decades, so the same issues still exist. So.
For information security professionals, would you recommend maybe looking at open source alternative for a gateway like PFSense or OpenSense or one of those?
If you like playing with it, sure. Everything's going to have its trade-offs.
Seems like you hit quite a few routers, so I'm wondering what is the most common stack you're seeing for these interfaces that are open on devices. Like you're seeing, I saw a lot of CGI in the presentation.
Yeah.
So the presence of that to a binary versus like interpreted like this.
For me, the most common that I can think of is a lot of Lucy, so compiled Lua, or Lie HTTPD serving some sort of PHP interface or CGI, or basically anything from like 2010 and prior is what we find on these devices mostly. I think we have time for like one or two more. No? All right.
Never mind, we have time for no more.
Yeah, thanks everyone.